my career with and that's where I started my career with, which was with industrial process automation, and then kind of slowly expanded into this subject. So it's like about 15, 20 years or a little more, though not everything is in robotic, but started with automation surely. And this particular, what should I say, set of information which I'm sharing is more from the point of view of for people who want to kind of either use it, apply it, buy it, or kind of influence the decision of it, and not getting into the subject in the direction of how do we go about creating a program or creating a logic. So this is not meant for people who want to become a hardcore machine learning engineer. It is more for people, okay, how do I use all this? I think that's what we want. How the technology works is one aspect of it, but what's that technology going to do for us? So that is what we will kind of um, orient this discussion for the next 45 minutes, yes. And then we will open it for about 15 minutes so that everybody has something to share on what we have done. And maybe another, I'm not going to exceed more than 1 hour and 15 minutes probably. We have done already about 15 minutes. So yes, we spoke reasonably a little about it. It comprises everything. Of course, everything starts with process. We are assuming that all the processes are in place and they are tightly kind of, have parameters to measure the elements of the process, the effectiveness of the process. Then comes automation, and then comes robotic process automation. If your processes are not tight, if the parameters are not defined, or if the transactional parameters are not defined, or the ratio parameters are not defined, then dreaming about or even applying concepts of robotic process automation will not help you in any way. That's kind of a pre-rider. So we are assuming everything is in place, first assumption. Now, going back to I'm going to talk about it. It's end of the day, as it was also summarized with, the robot is just like a child, or it's a machine, and the machine is as intelligent as how you have programmed it to be, or you have given sufficient information to be, and how it has. We will not get into the details of, essentially, in the form of a logic, in the form of mathematical equation, empirical equation, whatever. What the machine is supposed to be doing is being programmed. If that is not right, though it is expected to learn, but if the core of it is not right, you are going to be having a challenge on the effectiveness of how the robot is going to function. And when I'm saying robot, it need not be a physical robot. Like there was a gentleman who explained about a physical robot, which is an industrial robot used for air conditioning cleaning, to messenger robots or soft robots. But the subject which we are talking, which is process automation, which is business process, or for that matter, any of the business process, predominantly will be revolved around soft robots, or what we call as just bots. So just to set the, this is a slide which we shared before. So we started with the subject intelligent process automation. We did try to understand, obviously it comprises of artificial intelligence and robotic process automation. We covered artificial intelligence in the previous discussion. I'm not going to get into detail. However, for the benefit of all, I'm just going to kind of, what is artificial intelligence? Basically, as the word indicates, trying to get your machines as intelligent as what you are as a human being. I mean, we always have this dream of wanting to see machines do what we can, and then later start worrying about whether they're going to replace us. We'll not get into it. And some of the aspects are machine learning, deep learning, cognitive computing, neural networks, computer visions. Now, these are the elements of artificial intelligence. As I said, we did this in the last session, but for the benefit of all, of which machine learning is one key thing. Eventually, it is about how the machine learns. Of course, yes, you've given all the basic inputs, data, information from your experience, or from the experience in the business, or in the various processes of the business. And on top of it, then the machine starts learning in different ways. Could be supervised, unsupervised, reinforcements. There are some examples also given around. I'm not going to repeat what is already presented in the slide. So how machine learning helps? and what are the various applications which can get into when it comes to from the user perspective is kind of put into a structure in this. So these are all again elements of AI. Fascinating applications of deep learning. We want a vehicle to drive on its own. We want the system to recognize our voice. Like, for example, we wanted to kind of recognize handwritings. We wanted to probably even start recognizing, translate, which is from languages. For all that, what a human being does is what we are aspiring for all these machine learning applications or deep learning applications to do over the period of time. How far we are and how far we could is what we will have a look at. Okay, now eventually all this need to kind of what? It has got to help us do our business better, conduct our business better, or conduct our lives better, or make our lives better. The whole purpose of all this. So some of the industries which has adopted to them, and if you see, okay, all the industries do adopt. Predominantly the area where it has been adopted is in the service operations or in the product development. These are the major two areas where most of the applications have been utilized. And if you look at one specific industry which employs a lot more is automobile manufacturing. I mean, we understand for the simple reason, like about, if you look at manufacturing industries and specifically automobile manufacturing industries, once again, the adoption of artificial intelligence techniques, methods, algorithms has been far more higher for the simple reason. I mean, if you really look at, like as kids, any kid, the first thing we would want to is disassemble and assemble. And automobile industry eventually is all about assembling, not disrespecting the rest of the aspects of R&D, etc. But once everything is engineered, it needs to be assembled the same way. So it is just a repetitive task, actually speaking, which needs to be performed consistently, besides the advancements of the performance of the machines or the performance of the engine or any other specific parameter. So these are the various industries, and in particularly service operations, which is where we are going to kind of orient our subject towards, because when we talk about process automation and robotics, it covers predominantly service operations, meaning, as was initially said, repetitive task, but which needs to be consistently performed to a specifically defined quality level. Now, the moment we talk about automation and robots, one aspect which comes in, which would probably you would come across, is called as natural language programming. Once upon a time, NLP meant neural linguistic programming, which was predominantly used by psychologists to understand how the neural network works within a human being and how a brain functions and why do we behave in a specific way and why not in a specific way. Now NLP becomes natural language processing, which means a machine being able to do or receive inputs in the form of how a human being receive inputs. We receive inputs by what? By what we see, what we hear, what we feel, what we listen. So we would want a machine also to do that. And there are certain development which has happened. So one area is NLP. What does it do? Understand, classify, then kind of perceive as what the machine perceives, and enables a dialogue between a machine. Siri is a classical example of NLP, or Amazon Echo is a classical example of NLP, and it recognizes you what you speak, and then it kind of helps you to take some decisions. Okay, this being just kind of what are the elements, what we did before. Now we get into like, fine. Eventually, all this is supposed to help me automate my business process in an intelligent way, and one component of it being RPA. Now, how do we do it? So first, as like in any normal, again, when we said, the assumption is that the processes are identified, the workflows are in place, they have been tested, and the business parameters are kind of identified, the success parameters are identified, the handover parameters are identified, the monitoring parameters or ratios of the various processes are identified, and it has been put in practice. This is a big assumption and the premise with which we start talking about RPA. Is it really so or not? So talking about robotic process automation, if your processes are not already tightly defined and managed, then it's surely an organizational waste of time, mind, energy, everything. So let's not get there. I mean, just to drive from the example, say for example, this gentleman said, that's not a soft robot, it is a hard robot, which was used for cleaning the AC ducts. Now, for cleaning the AC duct, now what are the things? You have set in certain parameters. Okay, fine. If my compressor temperature, oil temperature is so and so after prolonged usage of so many hours, or if my output airflow has got reduced from so and so, or you put in certain parameters and then you say, fine, now this is the time for cleaning the duct. However, as the same thing, if you look at visual inspection and manual inspection, which is what he was saying manually when it was being done, it helps you to identify certain other layers of physical behavior of the system, which you will be able to see and then kind of identify what needs to be done. So is the robot as effective and as productive as what the human being was able to do? No. Why? Probably all the inputs were not sufficiently provided to the robot. Now, having a robot for the sake of saying we have a robot installed, and if that gives you some mileage to kind of do your business better, I don't know, maybe. Do we want to do that? Not sure. So identify, have a clear blueprint and model for what you want, execute. I mean, this is pretty simple. We all understand that in any business, this is the same. No changes, except that now we have certain things called, we have cognitive analytics, we have a voice bot, we have a content management system, we have a human and a digital workforce, which needs to be kind of now clearly defined who's doing what. And we are going to be having solutions from cloud, maybe hybrid, maybe in situ or on-premise, and then we need to work together. Now, the classical question of it just came in on the chat also, does it mean we're going to lose jobs? No. I mean, if we are smart enough, probably, we will make a robot to do what 4 human beings were doing and then have 10 human beings to kind of design that robot. So are we going to lose or are we going to gain? It depends on which industry and what scenario we are talking about. So that's so much so on this. Okay, so all this natural language processing of all the components of artificial intelligence seems to be the one research and technology development is happening, for the simple reason the interface and the human machine interface which we are talking about, we want to make it as simple as how a human and the human interfaces. When 2 human beings interface, we use all the methods of communication, and ideally we would want also the human machine interface to be as smooth as that, so there is maximum amount of energy being put by all organizations on this subject, which is called natural language processing. Simple. The machine translates, converts it into information, and there is a word which is very carefully which is being used called sentiment analysis, which human being does effectively. Are machines now trained enough, cycled enough, reinforced to learn enough, supervised and unsupervised to learn enough to even derive at sentiments, is what everyone is trying to appear or trying to kind of work on. Be it a Google, one of the major organizations which seems to be or having advanced a lot on this area is Google, and the other one is Amazon. To the extent where eventually the machine should be able to question even a human being and start learning like the way we human beings do. Okay. Now, where does robotics come into picture? Now it all gets together. Now, when you talk about artificial intelligence, we expand it or we kind of categorize it. One is vision-based intelligence, which is to do with what the eyes, that's what we said. Yes, we want the machines to become as powerful as, like, we have 5 senses to cognize anything, right? We have what we can see, what we can hear, what we can smell, what we can taste. Now, what we can smell and what we can taste, the machines, can they do? Possibly not. But what we can sense, what we can hear, and what we can see, the machines can also be made to. So that's why these 3 things come in. You have vision intelligence, then natural language intelligence, which is to do with voice recognition, speech recognition, etc., etc. And the last one is to do with, and it could start sensing like the way human beings can sense. And if these three can be achieved, probably living as I